For women ages 18 to 24, systolic blood pressures are normally distributed with a mean of 114.8 and a standard deviation of 13.1. If a woman between the ages of 18 and 24 is randomly selected, find the probability that her systolic blood pressure is greater than 140. Then, in Part B, we'll select 4 women between 18 and 24 randomly, and we'll find the probability that their mean systolic blood pressure is greater than 140. So keep in mind, Part B, we're making a sample, we're taking a sample of 4 women and finding the mean blood pressure. So the calculations will be slightly different between Part A and Part B. So first of all, let's look at Part A. Now we need to take 140 and convert that into a z-score. So we know how to do this from previous section. We want to take 140 minus the mean, which in this case is 114.8, and divide by 13.1. So throwing this into the calculator gives us 1.92. So that's my z-score. I need to find the probability on my standard normal distribution table of a z-score being less than 1.92. Now what that'll do is give me the probability that one of these women who's randomly selected has a blood pressure less than 140. But of course I want greater than. So I'll take whatever I get as less than and subtract 1 minus that. So let's look at the table. So here's my standard normal distribution table, and I'm looking for the z-score 1.92. So it looks like we're going to be at 1.92 is 0.9726 below 1.92. That means I've got there's 0.9726 below the blood pressure 140. So that is the probability that a blood pressure would be below 140 is 0.9726. So if we want the probability to answer this question, we need the probability that a randomly selected blood pressure is greater than 140. We just have to take 1 minus 0.9726, and that gives us 0.0274. So in other words, the probability that a randomly selected blood pressure for one of these women would be greater than 140 is very low. It's 0.0274. Now let's look at Part B. Here we want, we're selecting 4 women. That's our sample size. We want to find the probability that their mean blood pressure is greater than 140. So let's find the z-score here, but of course in this case, since we're dealing with a sample, the formula is slightly different. We take our 140 minus the mean, 114.8, but this time instead of dividing by the standard deviation, we need to divide by the standard deviation, which is itself divided by the square root of our sample size. Now, if you're plugging this into your calculator, you want to be careful with parentheses. So let me just demonstrate how I would enter this into my calculator. I would start with an open parentheses, and what I'm going to do is enclose my numerator. So I would take 140 minus 114.8, close those parentheses, so that's my numerator. Divide that by, and then open some more parentheses, 13.1 divided by square root of 4, and then close the parentheses. So the z-score here after that calculation will be 3.84. Now, without even looking at my table, I can tell you that the probability of getting a z-score less than 3.84 is about as high as you can get. So the probability that my x will be less than 140, and really what we're talking about is our mean. That's going to be 0.9999 because that z-score is so large. So that means the probability that my mean is greater than 140, that's going to be 0.0001. Now, depending on what table you look at, you might be told to put 0.9998 here, which would make this 0.0002. Either way, those probabilities are so small and insignificant, it won't matter in the end.